Lesson 7.8, Inverses of Relations and Functions, Part B. I wanted to wait and do this one, making sure I had enough time, because the alternative to showing if two functions are inverses or not takes two steps. The first one we showed already, where you were to take one function, switch the x and the y values, after changing the functional notation to a yx notation, and then solving for y. In doing so, if you get the other function, they're inverses. Now, the second way is to take and do a composite function. In other words, if I do f composite g of x, that's equal to f of g of x, which is equal to f of, and since this is g of x, I'll plug that in, 4/3 x plus 8. And that equals then 3/4. I plug in my other function, 4/3 x plus 8, and then minus 6, finishing it out. Alright, that will then take a new shape after I distribute. And notice I have 3/4 times 4/3. They are reciprocals. They cancel out. 3/4 times 8 gives us 6. And that gives us x. When you plug one function into another and they're inverses, you should and need to get x out of all of that in order for them to be considered inverses. Now if we did the opposite composite, because we said order mattered, in this case now I would do g of, or g composite f of x, which is equal to g of f of x, which is equal to g of, and f of x is 3/4 x minus 6. And if I substitute all of that into the g of x function, I will get 4/3 times 3/4 x minus 6 plus 8. Again, we distribute. And that will give us, again, 4/3 times 3/4 will give us just x, because they are reciprocals of each other. And then 4/3 times a negative 6 is a negative 8 plus 8. And again, we get x. So again, I mentioned that there's two steps, and that is to do both composite functions to make sure that we get x when we're done. And this ends lesson 7.8.